Hi, guys. I was asked to solve a problem in Chapter 6, and I will do so by, well, first let me show you the problem. Student sent me a request through Ask My Instructor, which of course you're all welcome to do when you can't solve it by the other methods, such as show me an example or some of the files that I created to solve more difficult questions in subsequent chapters, I think starting in Chapter 7. But here's the problem. I think I'm not sharing. Hold on, let me share. Share. Okay, that's a big mistake. Okay, so we are sharing this. This is the problem in Chapter 6, number 6, I believe. And let's read the problem. Just give me a second to get organized here. Okay, so a company has a recent batch of batteries that has a group of 20 batteries. 6 are bad. So the probability of picking any random battery that's bad is 6 out of 20, which is 30 out of 100, which is 30%. Now we choose 2 batteries at random, and we're asking for, first of all, something about the assumptions of the problem, the verbal part of it. In part A, has the assumption of independence been met? Because if the answer is yes, then you're allowed to multiply the separate probabilities. But it turns out the answer is no. They're not independent. They're in fact dependent, because the effect, if the first battery is bad, that means we know that there are only 5 bad batteries left. So the probabilities go down, as you'll see when we do the calculations. So the answer to the numerical question is no, because the outcome of the first battery affects the probability that the second battery is dead. That's part A. Then it says, part B, calculate the probability of either 0 good, 1 good, or 2 good. What is it, 2 bad? What is it? Again, we're choosing 2 batteries, so either both of them are bad, so they have no good, or one of them is bad and one of them is good, or both are good. Okay, so those are that's called the sample space, and we're asked to find the probabilities. Now, because I don't have a blackboard to sort of show you simultaneously, let's solve it by help me solve it. Okay, so I'm going to go through the steps pretty sequentially, as you would do, but with me filling in the blanks. Okay, when the 2 events, blah, 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 continue. So again, the numbers might be different, or maybe not. Okay. All right, so I already addressed that. The answer is that they are dependent, because the effect of, if you pick with the first battery and it's dead, then that affects the probability the second battery will be dead, or the opposite, good, and vice versa. If your first battery is good, that affects the chance that the next battery might be dead. It affects it in a small way, but it still affects it. Then it says, what are all the possibilities? Well, if you're picking 2 batteries, the answer has to be, for X, meaning the outcomes that are possible in this case, either a 0, 1, 2. That's the answer. Check answer. And so far, so good. Then it says to calculate the probabilities of 0, 1, or 2. Well, again, my limitation, they're going to use the following formula, that if the probability of 2 events happening, A and B, where A and B are independent, then you simply multiply it P of A times P of B. But if P of A and B are not independent, as they are here, you have to use a slightly more sophisticated formula calls Bayes' formula, that the probability of A and B happening, here A refers to the first battery is good, and B is, well, actually bad, because X equals 0 means there are no good batteries, meaning they're both bad. The chance that the first battery is bad and the second battery is bad, which is B, is P of A, the chance that the first battery is good, times the probability that the second battery is bad, and that vertical line means given that the first battery, A, refers to the first battery, was bad also. So the chance that A and B are both bad, that both batteries are bad, which refers to A is the first battery is bad, and B is the second battery is bad. In other words, the chance that no batteries are good can be gotten by that formula. Well, P of A is easy. What's the chance the first battery is bad? Well, there are 6 bad batteries and 20 altogether, so it's 6 out of 20. So the answer to P of A is 6 out of 20. The answer to P of B, given A, well, if the first battery is bad, how many bad batteries are left? Well, only 5 are bad, right? Because we just picked. And how many batteries left? 19. So the answer is 5 out of 19. So let's put this in numbers. Continue. The first battery is dead is going to be, as I just said, 6 out of 20. I'm waiting for it to decide that I'm right. The chance that the second battery is dead, given, again, that vertical line is read as given or assuming, or we know for a fact the first battery was dead, that's going to be 5 out of the 19 batteries left. And the chance that they're both true is going to be 30, 6 times 5 divided by 20 times 19, which is 30 out of 380. So it's 30 divided by 380. I don't need the calculator yet for this. No, I guess I made a mistake. 6 times 5 is 30. 20 times 19 is 380. Sorry, yeah, 380. Oh, it's asking us not to put in a fraction, to round it. So I got to take out my phone and write out, I made this mistake preparing this, 380 equals 0.0789, which rounds to 0.079. Let's put down, let's erase this, 0.079, enter, and we got it right. So it's almost 8%. Now, determine the probability one battery is good. So one battery is good means that the first battery is good and the second battery is bad, because it's exactly one good battery. Exactly is an important point here. Not at least one, but exactly one. Or, and the or also is an important point, because or is dealt with by adding together the separate mutually exclusive probabilities. So the first battery is bad and the second battery is good. So that's going to be the structure of our solution. Of course, I've done it. I know it's right. Now, what's the probability the first battery is good? Could be stated as, okay, this is again the structure of our solution. So let's break it up into pieces. What's the chance the first battery is good and the second battery bad? Well, there are 14 good batteries out of 20. There are 6 bad batteries out of the 19 that are left. So the chance of getting exactly that happening, first battery good, second battery bad, is 14 times 6 over 20 times 19. So that's 84 divided by 380. That better be right. Yes. Then the chance the second battery is dead is, I'm sorry, the first battery is dead is 6 out of 20, and the second battery good is 14 out of 19. So it's 6 out of 20. And it's hard to write it, but it's 6 out of 20. So 6 out of 20, 6 out of 20 times 14 out of 9. So 6 times 14 is 84. Actually, the same probability as before. Of course, what's the difference? The first battery is bad and the second battery is good, or vice versa. It should be the same answer. And in fact, it is. Now they want us to add together those two separate numbers, but again, you have to round it to 3 decimal places. If you do what I did, 2 places, which is right, is good for most examples in the course, it marks it wrong. So let's do the calculation. 84 out of 380 is 0.221 times 2, because there are 2 of them, is 0.442. So I wouldn't bet my life on it, but I think it's 0.442. 0.442. That equals check answer, and it's right. And finally, what's the chance of 2 batteries being good? It means the first battery is good and the second battery is good. Well, there are a couple of ways of doing it. We can do it the same way we just did it, analyze it as the first battery good and the second battery good, which will give us 14 out of 20 times 13 out of 19, because there are 13 good batteries left. Or another way of looking at this, since all 3 numbers have to be, are only all the possibilities. So the chance of 0 plus a chance of 1 plus a chance of 2 have to add up to 100%. And we know the first 2 answers was 0.079 was the first one. And the chance of the second answer was 0.442. And that is 0.521. So how much is missing to make up 100%? So I minus 1, and it's 479. So the last answer has to be 0.479. But you might want to check it out both ways. And we're right. Continue. Oh, there's more yet. Oh, no, I'm sorry. I realize there's more to this, which is part of why this is video. Now they're asking you to calculate what's called the expected value. Even though we're going to get, sometimes we're going to get in this situation, no good batteries, 1 good battery, or 2 good batteries. The most likely is 2 good batteries, but there is a chance you may get. So what would happen on the average? If you did this time after time after time, repeated this experiment, sometimes you would get 1, sometimes you get 2, sometimes you get 0. So the formula is you multiply each outcome by its probability. So it's going to be 0 times 0.79 plus 1 times 442 plus 2 times 479. Well, that formula is right below us. They're asking us to do that calculation. And I don't have a pencil, actually, and I don't know how to use the cumulative. So let's try to see if we do this in our heads. So 2 times, let's do it backwards. It's going to turn out to be easier to do it backwards. 2 times 0.479 plus, which is 958, plus 1 times 442, which is 0.442, plus the 0 times anything is 0, so it comes out to 1.4. So the answer, if I did this right, is 1.4. I did do it right. Okay. Now, next comes the last and most complicated calculation. We want to calculate something called the standard deviation. Well, again, we just said that on the average, you're going to get 1.4. You expect to get 1.4 good batteries. Now, you'll never get 1.4. You'll get either 1 or 2 or 0, but we're going to get 1.4 on the average. Well, how much variation? We don't expect to get exactly 1.4 every time we do it. Sometimes we get 0, sometimes we get 2. There's a certain variation. That variation is measured by, first of all, something called the variance of the population or of this distribution. And finally, to make that variance into a number that's more meaningful, we take a square root. And by the way, let me give this as an advertisement to some of the videos that I made previously on this topic. That will be when I put this into a document to help you keep track of these WebEx that I'm making. Those will also be linked near it. Anyway, so the formula for the variance is you take each, let me see, You take each outcome, how much it deviates from the average, you square it, you square it and multiply it by how likely that particular number is going to show up, and then you add them all together. So it sounds complicated, and it is a bit complicated, but let's take they do it piece by piece, which is the great thing about this artificial intelligence. How much, 0 is how far away from the average. Well, 0 minus 1.4 is minus 1.4. 1 minus 1.4 is minus 0.4. 2 minus 1.4 is 0.6. And I know something's wrong because, I'm sorry, it must be 1.6 because, no, 1 minus 1.4, what do they do wrong here? Because all three of them have to add up to 0, and they don't seem to. 0 take away 1.4 is minus 1.4. 1 take away 1.4 is minus 0.4. 2 take away 1.4 is 0.6. What did I do wrong? 0 take away 1.4, x of 0, mu, or the mu, by the way, that Greek letter, that u is really pronounced mu, or me if you're Greek, by the way, minus 1.4. That is correct. 1 minus 1.4 1 minus 1.4. Oh, let's try that. Okay, I'm losing my mind here. 1 minus 1.4 equals minus 0.4, and 2 minus 1.4, 0.6. Oh, I'm sorry, that is possible. This is, I'm thinking of another formula involving the difference from the average. This is not an average. Okay, so this is probably correct. Okay, the next step of the formula is to take these deviations and square them, because basically you're getting rid of the minus sign. And again, I have videos explaining this in some basic detail. So minus 1.4 times minus 1.4 is 1.96. So the number that goes here is 1.96. 0.4 times 0.4, I can do that in my head, is 0.16. And 0.6 times 0.6 is 0.36. Check answer. And again, so far, so good. Then they're telling us to multiply 1.96 times 0, which is, of course, 0, 0.16 times 1, and so let's do it. 36 times 36 is 0.72. 0.16 times 1 is, oh, sorry, my mistake. 1.96 times its probability, 16 times its probability, 36 times its probability. Well, again, with a pencil and paper, that would be easy, or if I knew how to use the accumulation of the calculator, that would also be easy. So let's continue. Let's see what they tell us to do. Oh, they give us the answers. 1.96 times 1079, 16 times 42, 36 times 479. Now, what's that number going to be? I had a pen. I could do that. You have a pen? How many paper? Yes. Okay. I'm going to do that calculation. Take me a second. I apologize. I wish I could put this on hold, but you'll have to bear with me. 1.96 times 0.079 equals 0.8748. 0.16 times 0.442 equals 0.0707. And 0.36 times 0.479 equals 0.1724. Adding them all together. Let's do it. Computer calculator. 0.0707 plus 0.8748 equals grand total of 1.179, or rounded to 1.118. 1.118. Enter. Uh-oh. Let's see what I did wrong here. You know what? Instead of doing this, let's just check the answer a second time. Tells it, how the hell did that happen? No, my first number was a mistake. 0.079 times 1.96. Anyway, no one's perfect, right? 0.398. The next question is, the last step is to calculate the square root, because if you notice, we squared it to get rid of the minus sign. We want to see how far is each number from the middle, the average. By squaring it, but now we have to do the opposite of squaring, which is taking a square root, and the square root of 0.398, which 0.398 has to be bigger, 0.6308 or 0.631. Oh, again, what's wrong with me? 398, around to 2 decimal places. This is getting very annoying. I think it's something, a weakness in this whole system. You have to do exactly to the decimal places they tell you. So let's try that. That's my mistake, actually. All right, so we're done. All right, I hope this video helps you. And again, if you have any questions, make sure you email me or see me in class. Close. Stop sharing. Get out of this. End meeting.